All right, guys, integer series C here. We're going to look at integer multiplication today. Let's start with what multiplication is. Something simple like 6 times 2. What does that mean? Now, I also want to point out with the parentheses, some of you guys have been a little bit confused on parentheses. Here, they mean multiply. The way we can tell that is because there's nothing in between the 6 and the parentheses on the 2. The 6 is just bumped right up against those parentheses. I often would call that parentheses prison for the 2. Okay, so that 2 is trapped inside parentheses. There's no operation connecting it to the 6 except the parentheses, which tells us you have to multiply. Okay? So if we were to write out that multiplication, what exactly does it mean? It means we're going to take 6 groups of 2. And we're going to add them together. So we have this. Six groups of 2, and if we add all of those together, of course we get 12. Now it doesn't matter which way you do that. You could also go the other direction. You could also say 2 groups of 6. And we could just write that. And then we see 2 groups of 6 also equals 12. Okay, and you might be wondering, why, Mr. A, are we learning second grade math? I'll show you in a sec. Okay, so here we can see the definition of multiplication and what it exactly is. It's just repeated addition. Okay, that's what multiplication is. We're going to use that to discover how we multiply integers that have signs on them. All right, anytime you need to, remember, pause the video if I'm getting ahead so you can keep up and get all these notes taken. Next page. What if we apply that idea with a negative? Let's try something. Let's do the 6 and 2 again. If we see that, we see it's a multiplication, 6 times negative 2. And again, it is a repeated addition. So let's write that out real quick so we can see what's going on. We're going to have 6 groups of negative 2. And now the great thing about that, excuse me, as we go back to the lesson a couple days ago earlier this week, we're just adding a whole bunch of bad guys together. If we add bad, 6 groups of bad guys, what are we going to get? We're just getting a larger group of bad guys. Okay? And if we switch the negative to the front number, I want you to notice it doesn't matter because we can write that as repeated addition and just see this as 4 groups of negative 3. You're allowed to look at it either direction with multiplication. That means it's commutative. The order doesn't matter. So I can just write negative 3, and you guessed it, 2 more negative 3s. And again, we've got 4 groups of that negative 3. We're just writing out the multiplication. And we can see that all those bad guys add together into a larger group of bad guys, and we end up with negative 12. I just happened to be the same answer on those 2 problems. There's no association there. That just was luck. Okay? So notice you can write it out either direction. I'm picking to write it out backwards on this second problem, 4 groups of negative 3, just because then we see the negatives adding. It makes it easier for us to understand. And on the top problem, I wrote out 6 times negative 2 as a bunch of groups of -2, 6 of them to be exact, so we can see that we're adding all those negatives together, okay? And from these two, we can derive the rule that we get for multiplication. I'm going to try shrinking down this screen and seeing if it works. Yeah, somewhat. You guys can write below or next to on your notebook page. It doesn't matter. I just want you to see what I'm talking about while I write up here. So it turns out that with multiply with a single negative, the answer is negative. And that's always going to be the case. Okay? The reason why that is we see right here, when there's a single negative in the problem, you can expand it, and you're just adding multiple groups of that negative, which is a larger negative. Doesn't matter which way the problem is set up, you can always write it out as adding together a group of all those negatives, okay? So if we were to shortcut those two problems we just did, it's this simple. 6 times -2, it's 12. And there's one negative in the problem. That single negative goes to the answer because we just added up a bunch of groups of -2. -3 times 4. 3 times 4 is 12. And because there was a single negative in the problem, if we expanded it, we would see we're just adding multiple groups of -3, 4 groups of them to be exact. And that's just going to become -12 again. Okay? That's the shortcut. You guys, show me you can do that right now. -4 times 2. Don't answer it. Don't write out an answer. I want you to write out as the repeated addition, okay? Write it out right now as a repeated addition, and I'll give you one more to practice on. How about 5 times -3. Write it out as repeated addition, and then you can answer it. Go ahead and pause the video, and then write the answer. All right, I assume you paused the video. I'm trusting you. -4 times 2. I'm just going to write that out as 2 groups, because it's the positive number, 2 groups of -4. The reason to do this is for you guys to begin seeing, oh, that's really simple. -4 and -4 as I continue practicing my addition. Bad guys and bad guys, -8. Okay? So then if I were to shortcut this problem, -4 times 2 is -8. Okay? Second one, 5 times -3. We're just going to say that's 5 groups of a -3. 1, 2, 3, 4, 5 groups of -3. There you go. And we can see once we add all those together, that adds to -15. It's good to practice for our integer adding. And again, we can then shortcut that. 5 times 3, -15. A single negative always goes to the answer. All right, give me thumbs up if you get that. Ha! Some of you just thumbs up the video. Gotcha. All right. Let's point something else out here. These 4 problems are slightly different, and I want to point something out to you. If the negative is on the smaller number, okay, ignore the signs. I'm just talking about the 4 and the 5. Okay, when we talk about addition, the sign matters which number it's on, because there's good guys, there's bad guys, that affects the outcome. But in multiplication, notice, if the sign is on the smaller number, it doesn't matter. It still goes to the answer. A single negative makes a -20 for that one. If the sign happens to be on the bigger value, it doesn't matter. Negative 7 times 2, negative 14, the sign goes to the answer. If the sign is on the second value instead of the first one, it's bigger and it's on the second value, it doesn't matter. And if it's smaller and it's on the second value, it doesn't matter. A single negative always goes to the answer, okay? Now, hopefully what you're coming to right now is the realization that multiplying, and it turns out dividing, it's the exact same rule, is much simpler than adding and subtracting. There's a bit more to think about and work through and learn to add and subtract. Multiplying, really, really simple and straightforward. Single negative goes to the answer, and now let's look at what double negatives do. Use my stupid software. Oh, okay. Learning how to... All right, here we go. I'm going to use really huge numbers because I don't want you to multiply. I want you to focus on the sign. Just write the sign of the answer. Evidently, I'm stuck on 20s right now. Keep using those numbers. In fact, I could even substitute out numbers start using symbols. What's there doesn't matter. You simply need to look at the signs to come up with the answer. Take a minute and do those 5 real quick. Just the sign of the answer. So you're just going to write plus or minus over here. What's the sign of those answers? Go. All right. First problem. Single negative goes to the answer, and then we would just do the multiplying to find the actual number. Second one, pair of negatives. They cancel each other out. This is where we get the idea that pairs of negatives cancel, okay? We have to have a different solution than if there was a single negative. So clearly the negatives are going to cancel. We're going to get a positive answer. Single negative goes to the answer. Pair of negatives cancel out, positive answer. Single negative goes to the answer. It's as simple as that. All right. Jumping on. If negative 2 times 3, hopefully we're getting the hang of this, is negative 6. Because a single negative always equals a negative answer. Okay, that's always going to be the case. If that's the case, let's have you make a prediction right now. We're going to rewrite the problem slightly. Now we're going to do negative 2 times negative 3. Notice there's another negative. It's a 2 negative multiplication problem now. There are 2 negatives. 2 times 3 is always going to equal 6. Okay? So the real question is it going to be a positive 6 or a negative 6? Based on the fact that a single negative makes a negative answer when you multiply, what do you think is going to happen if there are 2 negatives? What's necessary? What are we going to have to do here? Think for a sec. Hopefully you said, oh, Mr. A, clearly if there's 2 negatives, it has to be a positive answer because we have to have something different than a negative 6. If a single negative stays in the problem, the pair of negatives must cancel, and you're correct. So a pair of negatives always cancels. which means we get a positive answer. Okay. That right there is everything you need to know to be able to multiply and divide any integers. This right here is everything. Single negatives will always result in a negative answer. Pairs of negatives will always result in a positive answer. Let's go to the next page. Okay. Those rules we just learned. A single negative is a negative answer. Pairs of negatives cancel. Let's take this idea a little bit further. That might look a little weird, but all I'm doing is multiplying a whole bunch of ones with each other. Those are just a bunch of ones in parentheses. And I'm asking you what the answer equals. Now we know that 1 times 1 times 1 just equals 1. That's why I'm using that number. All we really want to know is the sign of the answer. So if we look at that problem, how the heck do we apply it to more than 1 or 2 negatives? Think about it for a second. I'm going to tell you, but let's see if you can come up with it. Make a theory right now. Okay, let's look. First thing I often hear from students is they'll count up, and we see there is 1, 2, 3, 4 negatives, and there's 1, 2, 3 that are not negative. And so they might say more negatives makes a negative answer. That's not going to be the case. That's more the mindset of addition. The larger group wins. But that's not the case with multiplication. It's much simpler than that. What we want to do here is we just want to start counting up. Those two, if they multiply together, those negatives would cancel, and you'd end up with positive 1. If I were to multiply this guy and this guy, and remember, in multiplication, you can multiply anything within a group if they're all multiplying. That's called the commutative property and associative property. They can all multiply in whatever order. You're still going to get the same answer. So when those two multiply, those two cancel. And so now we're left with a positive 1, a positive 1, a positive 1, positive, positive. They're all positive, which means when you multiply a bunch of positive 1s, you get another positive 1. And let me explain to you a really easy way to look at that. Let's see if I can get rid of those extra signs real quick. I can. Good. What if we just do this? There are 1, 2, 3, 4 total negative signs in the problem. And 4 is what kind of number? It's an even number. So if we were to just put 4 negatives here that we're going to all multiply together, we can see, oh yeah, pairs of negatives cancel. Those two cancel each other. Pairs of negatives keep canceling, so that pair cancels each other. So it turns out in the end, any even amount of negatives cancel. And if all the negatives go away, it means you get a positive answer. And then on the other side, if we had a different problem, something like this, we would say there's 1, 2, 3 total negatives in the problem. And in that case, if we wrote out, since 3 isn't an even number. 3 is odd. That means we're going to end up with one of those 3 odds not having someone to pair with. These 2 will cancel each other. But this last guy here, he's got no one to partner with, no one to cancel with. He stays in the problem, and that means the answer to this problem would be -1, because we can't get rid of that last negative, and that gives us the other side of this rule. Any odd amount of negatives they don't all cancel. There's always somebody left over because it's an odd number. And that means you'll always have a negative answer. Okay, if you're not quite tracking, let's just do a couple. Oops, I just jumped really. Practice problems, and I'll show you. It's actually really simple. -2 times 3 times -4. So there's 2 things we'd have to do in this problem. We'd have to figure out 2 times 3 times 4. 2 and 3 is 6. 6 times 4, 24. So we did the multiplication. And then we're just counting up. There's 1, 2 negatives. That pair is going to cancel because it's an even number. All the negatives are gone, so it's a positive answer. Or I could do -3 times -1 times -2. And in this problem, again, 3 times 1 is 3. Times 2 is 6. So the real question is all the negatives. We have 1, 2 negatives. Those will pair and cancel. But there's 1 negative left over. Nobody for him to pair and cancel with. He stays in the problem. He goes to the solution. And we end up with a -6. And so we notice our rule works. If there was an even number of negatives, we get a positive answer. Because all those even numbers, they'll pair up and cancel. But if there's an odd number of negatives, one of them will always stay in the problem. It won't cancel. So you end up with a negative answer. Okay, you guys do a couple problems here. Take a minute, practice those 2. All right. You need to pause the video because I'm going to work them out right now. So pause it and then start again when you're done. If I'm looking at just my numbers, 4 times 3 is 12. 12 times 5 is 60. Okay, so I'm working out just the, no, 72. Ha ha ha, 5 times 12. Oh, I did 5 and I wrote 6. 5 times 12, there you go, is 60. Now I'm just counting up my negatives. 1, 2, they're a pair, they cancel. It doesn't matter where they're at. It doesn't matter if they're on bigger or smaller numbers. It's literally as simple as pair them up, cancel them out. Everything canceled, answer's positive. Second one, 2 times 3 is 6. Times 1 is still 6. Times 2 is 12. Now I've got to figure out my signs. There's 1, 2. They'll pair up and cancel. I keep looking for negatives. Oh, there's another one. Nobody for him to pair and cancel with. He's by himself. He stays in the problem. -12. All right, guys, there you go. Go try this on some of your homework practice.